Hello everybody, this is Mr. Gable. Here are the things you're going to need. The basics here, the iPad, the math notebook. Please make sure you're taking notes, your practice journal for the end of the lesson, and a good sharp pencil. I've also posted in the folder 1/4-inch grid paper and isometric dot paper. You're going to want to probably play around with both of those, so if you can print those out, that'd be great. If not, drag and drop them into Notability, and you can play around with them electronically there. Isometric graph paper is really fun, and you'll see what I mean in just a minute. So our title today is just going to be three-dimensional figures, and our learning target today is you will work to have a better understanding of how to recognize the different parts of a three-dimensional figure. You will also learn how to draw three-dimensional figures. So a couple different learning targets there. Make sure you copy that into your notes. Our title for today. I found that people that had really high scores, I'm betting if I looked at their notebooks were really in great shape. And you're going to be able to use your notes on the test. So the better notebook you have, the better test results you'll have. All right. So explain what you think that the difference between two-dimensional figure and a three-dimensional figure are. When I think about this, 2D is length and width, and 3D is that third dimension, so length, width, height, or depth, length, width, and depth. And the three-dimensional figure, obviously, we can walk around. I think about like the 3D printer versus just the printed copy that we hand out in class. So there's a couple things that I think about. All right, so determine if the figure is three-dimensional. Pause the video if you need a couple seconds, and I'll see you on the next slide. So you're right. The smiley face, 2D, and the other ones are drawn to represent three-dimensional. So you could argue you're right, they're not three-dimensional because they're in this film, but they are drawn to look three-dimensional. So that's what we're going with. You also see that they have a shadow, so that would also help indicate that. All right, now we talked some time ago about surface area. And surface area is obviously the area on the surfaces of any figure. Great definition. But anyway, what I did here was if we use this one square in here, so this square here, if we use that as a unit of measure, so 1 square, so this front face would have 6. Its back side, which would look like this, would have 6. The top side is going to be 1, 2, 3 squares, and the bottom would have 3 squares. And both sides, even though this side would be, the right side would be straight up and down, the left side we would see the fronts of those stair steps or whatever we want to call those, but it would still end up being 3 squares. So altogether it's 24 squares. 3, 6, 9, 12, and 6 and 6 makes 12 more, 24. So it has 24 square units. All right, so now I want you to go ahead and do this. I want you to try to draw. So this is supposed to be a three-dimensional or looking like a three-dimensional figure. I want you to see if you can draw, and you can do 1, 3, and 4. You don't have to do 2 because I did that one for you. But I want you to draw what the views from all the different sides would look like. Do this work in your notebook. Pause the video. And then when you've done that work, I'll see you on the next slide. All right, so here's what all of those fronts should look like. And then they didn't find the surface area of all the sides. They just found the surface area, or they're just really looking at the different views from the different sides. So this would be the front side. This would be the left side, and this would be the top. We already did this one, but I did all sides because the question was about surface area. And then this one would be front, left, and top. Now, note that we lose all dimension. We lose all the drops here because really on that top view, we're just seeing 1, 2 there. We're seeing the top of that guy, that's 3, and the top of these two, that's 4 and 5. Same for the archway. We really don't see other than that front view to give us really what it looks like. So this is a little odd, okay, but just drawing that top the front, and then the left one of the sides. All right, so here are some notes that I want you to add to your notebook. So a solid is a three-dimensional figure that encloses a space, and a polyhedron is a solid whose faces are all polygons. So a face in pink there is just that flat surface of the polyhedron. The edge here in blue is that line, and the vertex is where the angles meet, the corners. Okay, it's the point where three or more edges intersect. All right, and this is really important to have in your notebook because you're going to be asked to count faces, edges, and vertexes. All right, some more terms for you to add. So a prism is a polyhedron that has two parallel identical bases, and the lateral faces are parallelograms. So the base here is a triangle, and that's why it is called a triangular prism. All right, and a pyramid is a polyhedron that has one base, and then the lateral faces are triangles. So here we can see that triangle, the lateral face in blue, and the base is pink or reddish color, and that's more rectangular shaped or square shaped, so it gets the name rectangular pyramid. Okay, now we're going to learn how to draw a couple of these in just a second, but please make sure you have those definitions in your notebook. Pause it and then go ahead and add that to your notebook. All right, so here we are. Find the number of faces, edges, and vertices in one solid. All right, so why don't you try this on your own, and then I'll see you on the next slide. All right, so the solid has one face on the bottom, okay, and one face on the top, and then it has four faces all around it in the middle section, 1, 2, 3, and then the back side would be 4. So that gives you 6 faces total, okay, and then the faces intersect at 12 different line segments. So each one of these lines between the green dots, that's an edge, okay, and then the vertexes, okay, the edges meet at different points, and those are the vertexes. So it has 8 vertexes, 1, 2, 3, 4, 5, 6, 7, 8, and it has the 12 edges. Each line is an edge. All right. So find the number of faces, edges, and vertices of the solid. Go ahead and pause the video, do that work. So if we take a look at this solid now with a little different coloring, the solid has one face top and bottom, and then 5 faces on the sides because it's a pentagon. So that gives it 7 faces, and the faces intersect at 15 different line segments. So we count each one of these: 1, 2, 3, 4, 5, and then 5 more, and then 5 more on the bottom. That gives you 15. And then the edges intersect at 10 different points: 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That gives us 10. So there are 7 faces, 15 edges, and 10 vertices. All right, so let's do this one together. Find the number of faces, edges, and vertices of this solid. Go ahead, pause the video, do this work in your notebook, and I'll see you on the next slide. So real quickly, this one has 5 faces, okay? So it has a triangular face, it has a matching triangular face, and then it has 1, 2, 3 more. So 3 plus 2 is 5, has 9 edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it has 6 vertices: 1, 2, 3, 4, 5, 6. Bad counting there. 3 vertices on each base or face, excuse me. All right, let's move on. So now it's time to do a little drawing. I want you to draw a rectangular prism, and then I want you to draw a triangular pyramid. Try on your own, or if you want to just follow along with me, I'm going to do this step by step with you. So let's do this. So to draw a rectangular prism, we want to start with 2 rectangular bases like this. Note that they're kind of offset from each other. Our next step is to connect those vertices, okay? And then we really want to think about which lines would we not see. Well, we wouldn't see We wouldn't see any of those if it was really a three-dimensional solid. Now again, it's drawn to look 3D. It's not 3D because you're drawing it on 2D paper, but it's drawn to look 3D. And so these would be dashed lines. All right, make sure you add that to your notebook. Now, drawing a pyramid. This is cool, and it makes a very difficult drawing rather less difficult. So we're going to draw a triangular pyramid. So it starts with a triangular base. That's why it's called a triangular pyramid. And then we just put a dot up here. And now we're going to draw lines to that dot from each of the vertices. So in doing that, we're going to draw that, and look at that. We've got a triangular pyramid taking really good shape. Now the only thing we want to do is we want to think about which lines would be in the back. So we want to make those dotted lines. Your turn to draw a couple on your own. A rectangular pyramid, so that would have a rectangle base, and then a hexagonal prism. And I'm going to show you the rectangular pyramid. So again, draw a rectangle, draw a point above, and then draw the lines to that point. Okay, and you can see that. And then here is there's the line that we wouldn't see. We wouldn't see that dotted line in the back. And then here's a different view of that. If we were looking at it more kind of from the side, I think. All right, so that is a rectangular pyramid, and it gets its name obviously from the base. So what I want you to do right now is I don't want you to draw this in 3D. I want you to draw this. What would we see if we're looking from the top? What would we see if we're looking from the front and from the side? Do that work in your notebook, and I'll see you on the next slide. All right, so the front view is just that parallelogram. The side view is going to look like a square because we'll lose all that dimension. We'll lose that sloping look. And then the top view is going to be more rectangular. You'll be doing a lot of this work today in Big Ideas. All right, now for the same thing here, draw just the front, the side, and the top views of this solid. All right, and there they are. So that T from the top, we'd have no idea it's a T, or from the side, it's a T. They're putting this line in to show that that's the top of the T, the crossbar. Just kind of interesting they put that line in there. So I want you to go ahead and do this on your own. All right, and in doing this work, let's take a look what it should look like. So a square prism, just that square face, and then we're elongating that. And to me, I always argued that that was a rectangular, but it's really that's the face there that we get its name from. Okay, and then this is a pentagonal pyramid, so we drew a pentagon. We drew that point up here at the top, and then we drew lines to connect that from each of the vertices of the pentagon. All right, and then the front, side, and top views of each of those, you got it. Now, on the top view, if we were really just looking down, I don't know if we'd see those lines or not. We might. It would depend on, might just look like a plain old square. All right, so let's take some time now and do these 4 questions in your notebook. The mini assessment for today. This should not take you long, and I'll show you some answers in just a second. All right, so here are your answers. This is what they should have looked like. I note the dotted lines in drawings 1, 2, and 3. They really help say to me that those are the lines that are hidden or not seen. And then here, your friend's birthday party cake, drawn from the different views. All right, that's it for today. Now I'm going to show you your workbook pages. Please do pages 221 through 224 just as a little practice, and then you've got your Big Ideas homework already assigned for you there. Let me take a second and show you isometric dot paper. And again, I put this out there for you, and I think this gets pretty fun because it allows kind of that real 2D to become very 3D. I'm hoping I'm doing this right. Oops. We'll see if I got this. Let's move these around. There we go. And then let's bring this guy in there. And we'll just connect up 2 more lines. Come on, behave. All right, so there's my drawing on isometric graph paper. What's really fun is to go back to some of our earlier stuff and try